Good afternoon. I hope you are fine wherever you are. I want to welcome you to this my second session of mathematics, where we are going to just build up on what you have learned in the previous lessons. In the previous lesson, we will discuss something on the joint variation, but here now I want to discuss something on the another type of variation, which is called partial variation. And what do I expect you to know after this lesson? After this lesson, I need somebody to know what is meant by this partial variation, either in two ways: part which is constant and when it varies. Now feel free to ask any question that you have. We are going also to ask you some questions that we are going to answer in the comment section. So feel most welcome. We are following your comments and your answers. Thank you and welcome. Now, partial variation. Under variation, we discuss something on. We discussed that variation is just quantities that connect each other, where the change in one quantity or the change in one variable affect the rest. For example, in the previous lesson, we learned about joint variation, where we said it joins more than two variables. For example, in commercial arithmetic, we said that interest was given by principal times rate times time, but over 100%. Over 100%. Where I here represented interest, this one was principal, the deposit, rate, then time. You see now, the interest here is as a function of these three variables. So, when the three variables are joined in this manner, we call it a joint variation. But in our class today, what we want to interest on learners is the partial variation. In a partial variation, this one is an equation or a variation where we have got something like which forms something like a linear equation. For example, when you are in Form 2, you learn about a linear equation where you want to go to y being a function of x in form of mx plus c. Where we say y is a function of x. So you check x, y will also increase. But this one here was a constant, meaning it does not change. So a partial variation is a variation where one quantity varies as the other variable varies, and another part is constant. Okay? Now we want to go through some examples. And example number one, I always use this part of buying some quantities at the market. Then from the market we have a cost of transport. You see, you buy 90 chickens or 90 chicks at a cost of maybe one chick here. One chick costing 90 Kenya shillings. One chick costing 90 Kenya shillings. Then the cost of transport cost 520 Kenya shillings. Now, after buying your chicks at the market, you will not leave them there. You will have to transport them. So here, the total cost depends on the cost of chicks and the transport. The transport here is constant, but the number of the cost of chicks depends on the number of what? Of the number of chicks bought in the market. For example, now we can say our cost here is equivalent to the number of chicks. Let's say that this person bought n chicks. N chicks. So the cost here, the total cost is 90. We multiply by the number of chicks, which is n, plus the transport cost, which is 520 Kenya shillings. Now we will find this person spending this amount of money here. Now suppose number of hen bought, or the number of chicks bought were 15. Were 15 chicks. So to mean our n is equal to 15. What is the total cost? The total cost now becomes C is equal to, the total cost becomes C is equal to 90 multiplied by 15 plus 520. What you get there in the compensation become your total cost of buying 90 what? Chickens. Now, I want us to go through the questions that have been displayed there with number 3. The question number 3 that have been displayed there, and try to see how can we solve this particular problem. So let us have a place to write the question and try to work it out. Then you will see what are you getting. Now, the question reads that a quantity V is partly constant and partly varies inversely as the square of W. The quantity V is partly constant and partly varies inversely as the square of W. If W is 2 when V is 14 and W is 3 when V is 9, write an equation connecting the two. Now, what do we need to do here first? Learners, wherever you are, as you read the equation, try to come up with some mathematical expression of what you are reading. So we'll start with the first part. We have been told that quantity V. Now we write V. V here is the function. V here is the function. Quantity V is partly constant. So V is partly constant. Constant is written by letter K, any other letter of your own choice. Is partly constant and partly varies inversely. Something which is inverse, we can say that V is equal to inversely is equal to 1 over W. The reciprocal. If you say V is equal to W, this one is directly. But inversely, we get the reciprocal of what? Of that particular variable. So quantity V is partly constant and partly varies inversely as the square of W. So plus now we may need to introduce a constant again under that Q. So plus a letter N into the inverse of W. What is our inverse of W? Our inverse of W is the same as 1 over W into 1 over W. But we have been told it is the square of W. So the inverse of W is the square of W. So 1 over W squared. And we can simply say that now this our equation is V is equal to K plus, if you multiply the two here, you will get N over W squared. To mean V is inversely proportional to W, the square of W. But why am I introducing this K here? Partly, to me, it is not constant. W varies as the inverse of W also varies. So to mean you need to get some coefficient of that inverse of W. So this N here is constant of proportionality under the inverse of W. Then the equation is we need to get the equation connecting the two. Now, the equation connecting the two, then we find the V when W is 6. What do we do to get the equation connecting V and W? First, what we need to do is to come up with some simultaneous equations. And this simultaneous equation that we can come up with comes from the values given there. W is 2 when V is 14. W is 3 when V is 9. Now what do we say? W is 2 when V is 14. So we start with 14 is equal to K, because K is constant, so we don't have its value. That's why the value of K is not given there. So it's equal to K plus N. But what is our value of what is the value of W? What is the value of W? The value of W is 2. The value of W is 2. But we have W squared. So is 14 is equal to K or plus N over 2 squared. And you know that 2 squared is equal to 4. Then this one will give us our first equation. Then the second equation we have 9 is equal to K. K is constant, thus is equal to K plus N over W now here in this case is 3. Over 3 squared. This one will give us our equation 2. That one will give us our equation 2. So that if we continue, we can work out the fraction part. So multiply here by 4, multiply this one by 4, multiply this side again by 4, multiply here by 9, multiply here by 9, multiply here by 9. So that 14 by 4 we get 56. We can say we have 56 is equal to 4K plus N. Then we have 81 is equal to, that one is 9K plus N. So this one is equation 1, this one is equation 2. That one is equation 2. Now from here you can solve the value of N or the value of K using 3 methods. You can go with the elimination method, you can go with the substitution method, you can go again with the matrix method if you can do that. And for me, I will use the shortest route possible, that is elimination method. Because we have N as 1, 1. What I will only do is to subtract the 2 equations. And when I subtract the 2 equations, what do I have? N minus N becomes 0, so there's no need of writing 0N. Then 4 minus 9N we get negative 5. Negative 5K is equal to 56 minus 81. We have 5 there. Then we have negative 3, negative 35, and negative 35. Now what do? We need to get the value of K. Divide this side by negative 5. Divide this side by negative 5. Learners, what are you getting? K to be, in the comment section you can type your answer. K to be 5, to be 7. Our K is now 7. Now we have got K as our 7. What is remaining is to get the value of N. To get the value of N, pick one of the equations. Here, pick one of the equations. Where there's K, substitute by 7. Replace with 7. We can start with the first equation. 56 is equal to 4 into 7 because K is 7. 4 into 7 plus N. Plus N. Plus N. Plus N. Then we have that is 28. 56. 56 is equal to 28. 28 plus N. So take this on the other side, subtract with the negative. If you subtract, you get you get N to be 28. N is equal to 28. Now, but the question is, we get the equation connecting the two. We need to get the equation connecting the two. Come back to what you have here. First one, V is equal to K plus V is equal to K plus N over W squared. What is your K and what is your N? So write V is equal to K, but where is K? Because K is constant, what do you place? Where can 7? K is equal to 7 now, plus N over W squared. What is our N? Our N is 28 over W squared. And this is the equation connecting V and W. So learners, this is the equation connecting V and W. So here what we need first to get is to get the value of the constant and the value of the coefficient of W. Our coefficient of W is n. This n here is the coefficient of inverse of W. After getting it, come back to the equation here. Where there's K, place the value of K, which is 7, and where there's n, place the value of n, which is 28. And the equation connecting the two is this equation, where now we have V is equal to 7 plus 28 over W squared. And some people who are smart can just write V is equal to 7 plus 28 into 1 over W squared. Still okay and still accepted. Then the next question, get the value of that V when W is 6. Get the value of V when W is 6. Now that one is very easy. What do you need to do? We need to get the value of V when W is 6. Now what do you do here? You just write V is equal to 7 plus 28 into 1 over W squared. Then you say, but W is equal to 6. Now if W is equal to 6, V is equal to 7 plus 28 into 1 out of 6 squared is 36, out of 36 squared. Then what do we do? Here 4 goes here, 4 goes here, 7, 4 goes here, 9. Then that one is like we're having, that one is now as like we're having something like, because it is mathematics, you have must show your workings. V is equal to 7 over 1 plus that one is 7 over 9. So that the LCM here is 9. Then that one is 63 plus 7. We get V is equal to 70 over 9. And you can simplify, if you simplify into improper fraction, what you get there is your answer, mixed fraction. So V is equal to, that one is, we are having 7 and 7 over 9 and 7 over 9. That shows your answer. So you can go through the workings and see wherever you have a problem. You can type in the comment section just so that we can repeat. Now let's go to number 2. Let's go back to number 2. Learners, number 2, example number 2, which is reading us a quantity where P varies as T. Varies partly as T and partly as the square of T. And partly as the square of T. When T is 20, P is 45. And when T is 24, P is 60. Find P when T is 32. Now you say that one is also a kind of partial variation. But in this case, do we have a constant? Do we have a constant? From what you have been displayed there, number 2, example number 2, a quantity P varies partly as T and partly as the square of T. When T is 20, P is 45, and when T is 24, P is 60. Find P when T is 32. Now learners, in this case, do we have a constant? If you think we have a constant, you can type yes, and if you think we have a constant, if we don't have a constant, again you can type no. but it is a type of partial variation because we have one part which is partly as t and another part which is partly as the square of t. It is a type of partial variation, but here we don't have a constant. How do we go about this particular question? How do we go about this particular question? Our main aim here, learners, our main aim here is to solve the value of p when t is 39. The first thing we have to do is to get the equation connecting the two. So our quantity p values is equal to now n into t because t is not constant. Here t is not constant. It must have some coefficient. So when you increase this t, you multiply by this n, the value of p here changes. Then this p is partly values as t and partly values as the square of t. So again we need to have with another coefficient of t squared. So again value as t squared. So it is the kind of equation that we expect you to have because p values partly as t. To mean you increase p, you increase t, p increases. You decrease t, p also decreases. You increase t squared, p increases. You decrease t squared, t decreases. So here we don't have something which is constant. Now, how do we go about this? The first thing I've said is step number one, you have to come up with a simultaneous equation. Learners, you have to come up with simultaneous equation. So we can say, therefore, p is equal to nt plus mt squared. Now, we are being told that t is equal to 20 when p is equal to 45. Then t is equal to 24 when p is equal to 60. Now what do? We need to come up with our simultaneous equation where now we have 45. Equation number 1, 45 is equal to n. But where there is t now, what do we do? Where there is t, what do we do? Replace with the 20. n into 20 plus m into t squared. What is our t? Our t is 20. 20 squared. Then another question. This one will give us equation number 1. Then equation number 2 we have 60. When t n now t is 20 is 20. When t is 24. Sorry, 24 here. T is 24. T is 24. Then plus m into 24 squared. This one is equation 2. Now, what do we do? We have in a distance this we get 45 is equal to 20n plus 400 m. Then we have 60 is equal to, that one is 24n plus, that is 24 squared. 24 squared, learners. 24 squared. You can type your answer there, learners. 24 squared. Learners, you can type your answer there. 24 squared. 24 squared, we get 556 m. This is equation 1. This is equation 2. What do we need to do here now, learners? I've told you can use any method of your own choice. You can use substitution method, you can use elimination method, you can also use matrix method if you have time. to solve the value of m and n. So long as we are going to get the same values of m and n, there is no method which is what I mean, you can use any method so long as we can arrive in the same answer here. If you have more time, you can go through maybe matrix. I hope by now you are well conversant with the matrix method, substitution method, and elimination method. And the next thing here, because here no one is the same, we shall pick one of the unknowns here. For example, we can decide to use 24 and 20. So multiply the first equation with 24 and multiply the second equation with 20. So that what will you have? 24 by 45. We get 1080 is equal to 20 by 24. That is 480 is equal to 480n is equal to that is 400 by 24. We get plus 9600 m. Then we go to the second equation. We have 60 by 20. We have 1200 is equal to 480 n plus we have that is 576 multiplied by 20. We have 11520 m. What do we do now? We subtract equation 1 from equation 2. Subtract this one from equation 2, where 480 will cancel so that we remain with this. Now we have, learners, in the comment section we can write 9600 minus 11,500, 9600 minus 11,520. Minus 11,520, we get our answer becomes 96,600 minus 11,520. Our answer becomes negative 1920 m is equal to 1080 minus 1200. 1080 minus 1200. We get negative 120. Now divide this one by negative 1920. Divide here by negative 1920. So that what you get there is the value of m. What you get there is the value of m. Use a calculator. Negative 120 divided by negative 1920. We get what you get there is 0.0625 is equal to m. So there's the value of m. Then we can use that one to get the value of n. We can use this to get the value of n now. We can pick one equation here. You just pick one equation here. We can say that we have now 45 is equal to 20n plus, that is 400 m. What is our m? M is equal to 0.0625. What do we get when we multiply that one by 400? Multiply by 400. Your answer becomes 250. So we have 45 is equal to 20n plus 250. So take this on the other side so that you have this on the other side so that you have 45 minus 250 is equal to 20n. So if you do that, 45 minus 250 minus 45 minus 250 45 minus 250 you get that negative 205 is equal to 20n. Divide this side by 20. Divide this other side by 20 so that n becomes divided by 20 so that your n becomes 10 and a quarter. Negative 10 and a quarter. So n is equal to negative 10 and a quarter. Now we need to get the equation that is connecting the two. Now we can say that P is equal to, because this one is negative, it is good to start with the positive part. And what is the positive part? Is this one. So we can say P is equal to 0.0625 m plus negative, now it will not be plus but minus, because of this negative, minus 10.25 n. So this one, not n, this one is t. T, but here we have t squared. Because this one, the coefficients of t squared, which is here, m is the coefficient of t squared. And what is the value of m? 0.0625, which is this one now. Then the value of n is negative 10.25, which is here now. So this one is the equation connecting the two variables. Now, after having this, our question was, we were supposed to get the value of what? We were supposed to get the value of P when t was given. We were supposed to get the value of P when t was given. Now, what is the value of t? What is the value of P when t is 32? Now you are supposed to get P when t is 32. Now what do? We just come back to our equation. Sorry, do we come back to our equation? We come back to our equation and say we have P is equal to 0.0625 t squared plus minus 10.25 t. Now, where there's t, replace with 32. So that we have P is equal to 0.0625 into 32 squared plus, now it is minus 10.25 into 32. Then now, what do? You take your calculator and type in the comment section the value that you are going to get there. So we have 0.0625 into 32 squared into 32 squared minus 10.25 into 32. Then what are you getting? You will get that when you calculate out this, P is equal to negative 264. That's now the value of P P when T is equal to 32. So the lesson was all about the partial variation, and what you are supposed to know that partial variation can be either constant or when the two are varying. When the two are varying, you must have the two coefficients. But when one part is constant, we only have one coefficient. And that's how we calculate the values of P and where do we have the equation connecting the two. Thanks for your time. Thanks for watching. That's the end of the lesson. We shall meet another time. Thank you and bye. You can subscribe to the channel. Subscribe to the channel, you people, the learners. Subscribe to the channel.